today, one of the big parts about geometry are these ratios. They're called trigonometric ratios. You're going to see them all the time in geometry, so we're getting a really good introduction to them today. There are 3 of them. And if you remember from yesterday, we did the Pythagorean theorem, right? So the Pythagorean theorem, a squared plus b squared equals c squared, that helps us find one missing side if we have the other 2 sides already. However, we don't always have both of the other 2 sides. So that's when we use trigonometric ratios, is when we're missing more than just one side and we need to find the other sides. And they're basically ratios. If you remember, that word ratio means a fraction. So we're going to be setting up a bunch of fractions here. Specifically, these trigonometric ratios help us with right triangles. So the first thing we're going to do is draw a nice right triangle. Right triangles specifically have a right angle, so make sure you label that right angle in there. And then I'm going to label this triangle very specifically, okay? So when in geometry we're talking about angles, aka the vertices of a triangle, all these corners, we use capital letters. So I'm going to call this A, B, and C. Capital letters mean angles, usually in geometry. Then, also in geometry, we use lowercase letters, usually, to represent side lengths. So I'm going to say across from that angle, big A is little a, the side. Across from the angle, big B is the little b, the side length. And then across from the angle C is the little c, for side length. Okay, everybody got this diagram copied down into their notes, yes? We got uppercase letters meaning angles, we got lowercase letters meaning sides. Okay, so here are our 3 trig ratios. The first one is called sine. Sine, S-I-N-E. On your calculators, you will see it abbreviated to S-I-N. We do not pronounce that sin. That is sine. That's one of Miss Lisa's pet peeves. That's sine. Okay, and then these trig ratios are giving us the relationship between different sides of this right triangle. So it's going to be in relation to an angle, okay? We're going to talk about sine is the relationship between an opposite side and the hypotenuse. So that's opposite over hypotenuse. Now, what does that mean? Okay, I'm going to give us an example here. We have to specify what angle we are looking at in a diagram. So I'm going to relate everything in this first box to angle A. Now, the side length that is opposite to angle A goes all the way across my triangle. So this would be my opposite here. The side length that is the hypotenuse is obviously across from my right angle. So this guy right here, our longest side, is the hypotenuse. So if I were writing this trig ratio out, I would say sine of angle A, specifically because I'm looking at angle A, I'm focused on that angle, is equal to the opposite side is little a, and the hypotenuse side was little c. Okay, so it's a relationship between those 2 sides together. Does that make sense so far? Any questions on that? Okay. The next definition is cosine. In your calculators, that would be abbreviated C-O-S, not cos, not cos. That's cosine. And if sine is the relationship between opposite and hypotenuse, cosine is the relationship between what we call the adjacent side and the hypotenuse. That word adjacent means right next to. So for example, I'm still focused on this angle A. So I know the opposite is across the triangle. I know the hypotenuse is across from the right angle. That adjacent side is the one that is directly next to the angle. It touches that angle. It's one of the sides of the angle, but it's not the hypotenuse. Okay? So then this relationship, for example, if I'm talking adjacent over hypotenuse, I would want to write this as B, the adjacent, over C, the hypotenuse. All good so far? And then the last one is tangent. In your calculators, that's abbreviated as TAN. And now tangent is the relationship between opposite side over adjacent side. So let me write a little example here. Again, still focusing on tangent of that angle A. If I want to look at the opposite side to angle A, remember opposite was over here, it's that little a. And the adjacent side is over here, that's little b. Everybody got this copied down. This is going to be a real big part of this whole unit is these trig functions. So we got it? Okay. So we have a little mnemonic device to help us. We use this all the time. I still say this out loud when I have to do these. It's SOHCAHTOA. It doesn't mean anything, but it just is a little bit of a mnemonic device to help us remember these relationships. So let's go through what each of these letters mean. So is the first part. The S stands for sine. The O stands for opposite. And the H stands for hypotenuse. If I can fit it in here, I don't think I can. I'm going to try. Okay? So when I hear SOHCAHTOA, so reminds me that sine equals opposite over hypotenuse. Okay? Everybody got that? The next one is CA. Obviously, it's kind of the same idea. C stands for cosine. The A stands for the adjacent side. And the H stands for, again, that hypotenuse side. I won't write it all out because it's not going to fit. So when I hear CA, I'm thinking cosine equals adjacent over hypotenuse. So that's CA. The last one is TOA. The T stands for tangent. O stands for opposite. And A stands for adjacent. So TOA reminds us that tangent equals opposite over adjacent. Everybody got those in our notes? So oftentimes when I start these problems, I like to write out literally on the top of my paper, SOHCAHTOA, because that's going to help me do all these setups. Okay, good on the definitions right now. Things are going to get a little bit tricky. We're only going to do these top 6 for today. I'll come back to the next ones tomorrow because this is going to be a lot. The first thing that we need to look at when I look at a trig ratio is what angle am I looking at in my diagram? Okay, so in this triangle, I have R, T, and S. When I start problem A, I need to look at what is the capital letter angle it's telling me I need to focus on. So in letter A, it says sine R. That means I'm going to focus everything I do on R. What other two of these problems talk about angle R? A, D, and C. Perfect. We're going to do these 3 first because these are all talking about R. I recommend you write this in pencil because we're going to erase it and come back to this same diagram with the other angle. But the first thing I do is usually label what all my pieces are. I know I'm looking at angle R, so everything has to relate to R. The easiest one is the hypotenuse. The hypotenuse is always across from your right angle. Okay, so that longest side there, that is the hypotenuse. Then I have to look specifically at the angle. Out of the two remaining sides, 21 and 20, which side is the opposite to R? 21. It's going across the triangle to 21, which leaves 20 as the adjacent, and I know this is the adjacent because it's right next to that angle R. If I was looking at a different angle, like if I was looking at angle T, these would not be the same. So it is very important that we make sure we're looking at the correct angle first. Okay, so then for these problems, in your homework, you're going to do the exact same thing. All we are going to do is set up this fraction and simplify if we can. So first, sine. I'm going to look at my notes here. I know my mnemonic device starts with so, ka, toa. The S is in so. So the two pieces that I'm looking for are opposite and hypotenuse. So I look at my diagram. The opposite here is 21 and the hypotenuse here is 29. So my fraction should literally just be 21 over 29. Oops. And if I could simplify that, I would. That's it. That's all we're doing for these. So the next one, letter C, is tangent. I need to check which mnemonic device am I using. Tangent is TOA. So the two pieces that I need here, opposite and adjacent. I'm going to look at my diagram. What did I label the opposite? What did I label the adjacent? The opposite should be 21. And the adjacent to R should be that 20. Just like we labeled it. Okay, last one then. For letter D, cosine. Now, I'm looking at my notes. I can kind of see it at the top of my screen here. Cosine is ka, A over H. So that's the adjacent over the hypotenuse. So I want, the adjacent side. Opposite over adjacent. Did I say that backwards? TOA, O over A, OA. Opposite is 21, adjacent is 20. So this is 21. Oh, I'm doing the wrong problem. Sorry, we're doing cosine. Oh gosh. Cosine is ka, adjacent over hypotenuse. I'm looking here. I was looking at the wrong problem. Ka, adjacent over hypotenuse. The adjacent in this problem is 20. The hypotenuse in this problem is 29. Okay, we see how these three pieces work? I'm going to erase my diagram because now I'm going to do the remaining three problems, B, E, and F. In the remaining three problems, B, E, and F, what angle do I need to focus on? Now I'm looking at T. So I'm going to highlight where T is. I'm going to highlight where T is in my diagram. I'm going to zoom in. I'm going to now label all my pieces. Out of 29, 21, and 20, what piece is the hypotenuse? What piece is my hypotenuse in this diagram? 29, 21, or 20? 29 is the hypotenuse. The hypotenuse is always across from the right angle. So that's H. Relating to T. Okay, look at angle T. What side is opposite to T? 20 is opposite T. So then that leaves 21 is the adjacent side, and I know it's adjacent because it's right next to that angle T. Okay, got our labels? So now I'm going to write my ratios. Let's start with letter B. What do we think for our ratio for letter B, cosine? 21 over 29. A for adjacent over H for hypotenuse. Beautiful. Letter E, sine of T. What do we think? 20 over 29. Opposite O over hypotenuse, h. And then lastly, tangent. What's our ratio, Max?
20 over 21.
Beautiful. 20O, 21A. Okay. We think we got it? Okay, flip it over. We're going to come back to those other problems tomorrow probably. Or not tomorrow, Monday probably. Okay, so the real nitty-gritty here. It's not going to always be nice and labeled for you. A lot of the times it is, but sometimes we have to draw our own diagrams. Sometimes we have to find missing pieces. So in this example, find the values of each expression for triangle ABC, where angle B is the right angle, AC has a length of 25 meters, and BC has a length of 7 meters. The first thing we're going to do is draw a right triangle. So everybody with me right here, draw a nice right triangle. That's triangle ABC. I know it's a right triangle. I'm making that angle a right angle. Now I'm going to put on labels. I know one label has to go on that right angle. What letter am I labeling that right angle with? B. Does it really matter where I put A and C now that I have B in the correct spot? No. I made this triangle up out of my own head. So I'm going to put A and C there. And now I'm going to label the pieces. It says AC has a length of 25 meters. So between A and C, that's where 25 goes. BC has a length of 7 meters. So I'm going to put 7 meters between B and C. Everybody got this diagram? Okay. The difference between this diagram and the one we just did is I only have 2 of the sides. How do I find that third side? Pythagorean theorem. Perfect. Oopsies. So Pythagorean theorem, if you forgot, is a squared plus b squared equals c squared, where c is my hypotenuse. So what's that setup look like for me here? Beautiful. We're going to solve this for a. So I'm going to simplify. I'm solving for a, so now I'm going to subtract. This is a squared equals 576. Remember how I solve this? Now that I have a by itself, I got to square root both sides to get rid of that square. What's the square root of 576? Beautiful. So now I can label this 24 right in here. That's 24 meters. Okay, good. Now I've got my whole triangle labeled, so now we can set up some trig ratios. Let's start with letter A. What angle am I looking at for letter A? A, B, or C? What's the capital letter right there for angle or for number A? Letter A. Yeah, it's an A. So that means I'm going to highlight A, and I'm going to write in pencil because I know I'm probably going to have to switch this when I talk about a different angle. But I'm now going to label my triangle with opposite, hypotenuse, adjacent. Let's do that really quickly. Hypotenuse across from the right angle. The adjacent is the one that's right next to A. And then the opposite is the one all the way across the triangle from A. We got it? We got it? Okay. Set it up for me then. Cosine A is what over what? 24, yep, adjacent over hypotenuse. A over H. Perfect. If we could simplify that, we would, but we can't simplify this one. Any questions on that one? Okay, letter B. What do we have to do first? Jaden.
You have to find the adjacent of, not the opposite of C.
Yeah.
Find the hypotenuse, would be 24 over.
Right. So the first thing that we see is that it's not talking about angle A anymore. It's talking about angle C. The hypotenuse should always be your hypotenuse, but now the opposite to angle C is over here, and the adjacent to angle C is over here. So what did we say sine was? Opposite over hypotenuse for sine. O over H, like so in SOHCAHTOA. SOHCAHTOA. So what are the values?
24 over 25.
There you go, 24 over 25. That happens a lot, actually, because when we switch these, when we switch what angles we're looking at, the opposite and the adjacent, they swap. So oftentimes we get the same ratio. Okay, good. Last one here. Tangent C. What two pieces do I need for tangent? Opposite, hypotenuse, adjacent. What two pieces make tangent? Opposite over adjacent. So let's look at my triangle. I'm still looking at angle C, so I don't have to swap anything around. What's the opposite? What's the adjacent? Beautiful. Any questions on this part? This is going to be like most of your homework for today. We're going to do one more thing that's going to be like the last bit. I promise it's not hard at all. The most important part. Everybody got your calculator out right now? Okay. Most of your calculators, if you're turn on your screens, if you look in like the bottom right corner, it'll say DEG. Okay? If yours does not say DEG, let me show you how you change it. Some of you, it might just say like a D on the top of your screen. I'm going to show you how we change that really quickly. Okay, so mine already says DEG, but yours might have to change. So we're going to go to, there's a fancy button. It's mode right up at the top. Yours might look a little bit different. Okay, you see the one that says mode? And you want to change it. It's probably on this one right here. It's probably on RAD. You want to switch it to DEG and hit enter. I'm going to come around real quick. Let me make sure everybody's calculator says DEG, or at least a D. DEG. Yep, good. Hit enter when you got it. Good, good, good. Everybody got it, everybody got it, everybody got it. Did you find yours? This one right here. This one, D degree. Yep, hit enter. Okay, you're good. Good. Found it? You found it? Yep, you're good. You found it? Everybody, did anybody not find the DEG part? You're good, you're good, you're good. We're good, we're good, we're good. Yours is weird. Okay. If you have one of these calculators, like the most ones that I have, you're going to follow exactly the same as me. If you have a calculator like Ashton, yours is going to be a little bit weird. You're going to put the number, so okay, I'm looking at letter A. You're going to put the number before you hit the trig function. If you have a calculator like this one, you hit the trig function first. Follow me. So I'm now going to my blank screen here. I'm looking at letter A. That says sine 15. So I'm going to hit SIN for sine, the number 15, and hit enter. I wish you get a decimal. If you have one of the weird calculators, you're going to have to do 15 and then sine. Did everybody get this decimal? Before every quiz or test, I'll probably do a calculator check like this, because if your calculator does not say DEG or D, you're going to get wildly wrong answers. Everybody got this? So, this whole bottom section, we are literally just going to round to the nearest 10,000th place. So 4 decimal places for this is 0.2588. That's it. That's all. Okay, let's make sure we know where all the rest of the buttons are. Go ahead, keep going. I'm going to keep going through this. Tangent 45. So I find the tan button, 45, hit enter, I got 1. Next one, letter C, cosine 60, cosine 60, enter, I got 0.5. Letter D, sine 65, find the sine button, find 65, yes. Oh, okay, you're going to have to hit this button again right here. Anybody else getting weird things in their calculators? Or everybody's kind of getting the same as me? Okay, so that was sine 65. That was letter D. Letter E, cosine 12. Oops. 0.9781, rounding to the nearest 4th decimal place. And then tangent 87 is the last one. Tangent 87. 19.0811. Any questions on this?